Hey, shut up. How do you purify an amine? Can you use silica gel in a column, or is that a problem? I feel like that's a problem. I'm not sure though. Do you have any other suggestions?
Like how to purify the amine
Yeah.
without doing
purify this
column?
amine? Yeah, because I feel like the amine might get stuck in there.
Okay. Yeah, that's a good question actually, and almost all of us face the problem to purify the carboxylic acid as well as amine. So if you didn't see my previous video on carboxylic acid, how to purify, then you can see the technique, especially the last ninja technique for the carboxylic acid.
Click the link right here.
Yeah. So now I'm going to explain how to purify amine, and can we use silica gel column or not, like even yes, or if it is not, like why, and how to do the purification. Okay, so let's see. I can explain you. Okay, so your question about amine, okay, NH2, if it is primary amine or like secondary amine, those amine can be aliphatic or aryl, aromatic amine, whatever, like suppose you have a group or something, whatever group or like something group, and also like tertiary amine. So especially the problematic is like primary amine purification. So once you synthesis this amine, so you can sometimes you can use silica gel column, but in that case you have to neutralize, like you pack your silica gel in the column and then run your desired solvent, like suppose hexane, and add 0.5% or sometimes 1% triethylamine, mix that mobile phase and run that mobile phase through the column, so that insert silica will be kind of basified, because silica, you know that silica is acidic and amine will stuck in the silica. But in many cases still amine stay in the like silica, like you might lose the product. So in that case, normally I don't take the risk to purify my amine with the silica gel column, because sometimes it works very nicely, sometimes you will lose everything. So without taking risk, you can do two things. Number one, so once you get the amine crude, suppose this is the crude, okay, so dissolve it in an organic solvent, little bit organic solvent like ethyl acetate, okay, and then in that solution then add 10% HCl solution, aqueous solution, okay, 10% aqueous solution. So what it will form, that HCl will form the ammonium salt with this amine. So like you can say NH3 plus Cl minus this compound. So is it visible? No,
It's worse. Yeah, keep it
okay.
on.
So this ammonium chloride salt will be forming, and then you can add like once it is from ammonium chloride, so it will be soluble in the water, okay, and then you can add ethyl acetate. Once it is ammonium chloride salt, then it will stay in the water, and then you can add ethyl acetate while the whole compound amine is in the aqueous phase, and then with the ethyl acetate, so ethyl acetate will take out other organic impurity, not your amine compound. So amine compound will stay in your aqueous phase. So once it is done, like separate, like do 2-3 times with the ethyl acetate, so remove all the organic and do not throw those part, like keep it, store it somewhere in a separate flask. Then so you will get aqueous part separated and organic part separated. Remember, since your amine is in the salt form, it will go to the aqueous part, okay. So now deal this aqueous part. What you will do, this aqueous part will be like, you can add now sodium bicarbonate or 1 molar sodium hydroxide to make like neutralized amine, free amine, okay. So once you do it, you will see, like once you add the sodium bicarbonate or like anything, but sodium bicarbonate is more safer to use, but it may take like longer time and also kind of risky. Remember, in aqueous phase it will be acidic, so when you are adding the sodium bicarbonate, it will make more effervescence of carbon dioxide, it can bump out. So add slowly, and then as long as it will go like above pH 7, then you will see like your solution will be kind of like cloudy. That means your organic compound is getting like free amine, so that's why it is decreasing the solubility, so the cloudy. And then you can again do the, once you added this neutralized like pH pH around or above 7, so this part now you can do extraction again with the ethyl acetate. Okay, let's see, you get this part where the pH is greater than 7 to like 7, but it should be less than 9 or something. So that means basic. Okay, so that means you have the free amine here. So once you get it, then again you can add ethyl acetate here and do the extraction in the SEF funnel, and then separate into two parts. One is organic part, another is aqueous part. So again, see, remember one thing here. Once you make it free base like amine above, like by adding the sodium bicarbonate, now you are doing ethyl acetate extraction. Now your free amine or compound will be in the organic phase. Don't throw this part, okay? And that's how, if you remove the organic solvent, dry it, filter it, remove the organic solvent, check the NMR. I hope you will get the pure amine. So here I'm doing one of this work. Let's see how I'm doing that. Here you see that I am taking hydrochloric acid making 10% solution, and here is my compound solution in ethyl acetate in a separatory funnel. So in this separatory funnel, my original crude compound like amine and with organic impurity. So I'm going to add the 10% ACl solution here in the separatory funnel. So so here you can see that I already made the 1 molar ACl. Like this bottle is actually 1 molar, but it is 10% ACl I made. So here I'm going to add the 10% ACl solution in this separatory funnel, while my compound, like whole crude, dissolve in ethyl acetate, like little bit ethyl acetate, not too much of it. So so once you added the ACl solution in this crude, then in the separatory funnel, then I will take the separatory funnel out and I'll make the shake. And all of you know how to use the separatory funnel. If you don't know, then you can see my video extraction in my channel. So just invert the separatory funnel, open the bend like that part, and then close it and shake it, and again bend out the build-up pressure inside the SEP funnel. So here I am shaking vigorously because so that the ACl can react with the amine from that ethyl acetate solution, because that is in the organic phase. And this process will be done like multiple times, like couple of times. So same as you do the extraction with the organic solvent, here I'm doing the extraction with like aqueous solvent, like aqueous ACl solution. So once then I keep it like this, and once the layer is get separated, so top part will be ethyl acetate and bottom part will be like aqueous ACl solution part, but here you will get your amine also. So do not throw any part until you get all the things at the end. So I am collecting the aqueous part where my interested compound is there, and on the top the ethyl acetate layer is there. So I will keep the ethyl acetate inside the separatory funnel, and then I will add aqueous ACl again, and I will repeat that process couple of times, and I will collect all the aqueous phase in a same flask. So here after doing the multiple times, then here I'm ready with my aqueous phase. So see, this is the aqueous phase I have collected like after a couple of time extraction with aqueous ACl solution. Now I will remove the
that part, like organic part, in another separate aluminum flask, and I will wash the flask because I'm not sure like all of the amine goes to the aqueous phase or not. So just for a backup or like safe to be safe, just wash those things out and keep it in an aluminum flask. So once it is done, then just keep aside that organic phase. Remember that that organic phase should take out your other organic impurity. And according to the theory and according to my previous explanation, all of the amine should form the ammonium chloride salt, and it should go this phase, like aqueous phase. Now I'm going to change the separatory funnel, and I'm going to use saturated sodium bicarbonate solution. So when I add the saturated bicarbonate solution, remember this aqueous phase has the HCl, and saturated bicarbonate solution should react with the HCl and form it should give the carbon dioxide. You can see that effervescence. So do add that saturated bicarbonate solution very carefully so that it cannot be vigorous, because it is a exothermic reaction. It can produce heat and it can pump out or like too much of carbon dioxide. So it's better to pour the saturated bicarbonate solution in a safe funnel. So take a big safe funnel. So in that case, it will be kind of safe. You can see here, like first I am just added a little bit of the sodium bicarbonate solution in terms of the HCl. So I'm just checking like it is not basified yet. So here you can see like I emptied the flask because I poured all the previous aqueous solution in this big separatory funnel, and still it is reacting. So I'm adding more of the sodium bicarbonate solution, and you can see that it is producing the effervescence of carbon dioxide. That means the all HCl is not neutralized yet. And in between this time, I also checked the solution with the pH paper, and you see that here the solution become cloudy. That means that is getting close to basified solution. So that means your amine getting free in that aqueous phase. That's why the aqueous phase becoming cloudy, because of the organic compound solubility is decreasing in the aqueous phase. So I'm adding more of the sodium bicarbonate, and every time when I'm adding, before adding, I'm checking the pH with the pH paper. So I'm not showing here. So once it is done, and when I have seen that with the pH paper, like it is basified or like close to base 7 or 8. So normally just make it 7 to 8 or maximum 9 pH. So then you'll see there is no effervescence of carbon dioxide, so that is cloudy. So now I'm gonna use organic solvent here. So this time this organic solvent will take out your free amine in organic phase. So remember, first you acidified, collected the aqueous phase, then basify with the sodium bicarbonate. Once it is cloudy, then you can add you can add ethyl acetate in the separatory funnel. So to be safe, I am adding a little bit more little bit ethyl acetate here, and now I'll just give a shake to just to take those compound in the organic phase, and just to react with the sodium bicarbonate. And be careful when you neutralize your acid with sodium bicarbonate and invert your separatory funnel. Make sure that you bend out the build-up pressure frequently, because it can produce carbon dioxide and build up pressure, and the separatory funnel can explode and also propel out. So just to be safe, like bend out frequently. Once you shake, then bend it out the build up pressure, and make sure that before inverting the separatory funnel, close the that knob. Now once it is shaken, then I'm going to add more ethyl acetate, because my compound are in the aqueous phase, so I need like good amount of the ethyl acetate to go in the organic phase. So here I'm using ethyl acetate, and this time I'll do this process again like at least 3 times. So first time I will add ethyl acetate, shake it and let it be separated, and And so here I'm adding the ethyl acetate, and once the addition is done, then I'll put the cap and invert the sub funnel and shake it, and also bend the build up pressure, and then I'll keep it to separate two layers. So again, bottom layers will be the aqueous layer, neutralized aqueous layer, and the top layer will be the ethyl acetate. And this time in this ethyl acetate you will get your free amine as an organic compound. So that organic compound will go to the organic phase. So let it be separated in two phase. The bottom again, the ethyl acetate is lighter than the water, so ethyl acetate will go top phase and water will be in the bottom phase. So once the these two phase separated, then I'm going to drain out my aqueous phase first in one clean Erlenmeyer flask, and once all the aqueous phase is taken out, then I'll take out the ethyl acetate part in another Erlenmeyer dry Erlenmeyer flask. So by this way, like I will repeat this technique couple of times. So here I'm changing more flask because the flask was done. So here I'm taking out the aqueous phase. Once the aqueous phase is out, then I will collect the organic phase in another separate another Erlenmeyer flask. So this is the organic phase with like your amine in ethyl acetate. So by this way, I will collect 2 or 3 more times. I will do the same thing, like collect the organic phase, and then all organic phase will go in the same container, and I am washing out the sap funnel. Excuse me. So now I am pouring the aqueous phase again to do the repeat extraction. So you already are seeing that I'm pouring the aqueous part. Now I'm going to add more ethyl acetate here and then do the extraction again, and I will put the sub funnel in this ring to get separated two layer. So you are seeing that. So once it is addition is done, then shake it again and just close the knob again. Make sure that before inverting your sap funnel you close the knob, so whenever you open, but again close it and then keep it in the ring to be separated. Once the phases are separated, again collect the aqueous phase from the bottom and top phase. So here in this flask you will see like I have collected all the ethyl acetate part here, and I added the sodium sulfate to dry the trace amount of the water from here, and I'm swirling it so that all the water is gone. So by this way just you can filter it and rotoweb and get the compound from here.
So there is a second option, you can purify your amine. So suppose you have amine, and if that compound is acid sensitive, like you cannot use acid for other functional group, so you can do one thing in that case, like you cannot do like acidify, make it in aqueous phase and do extraction with the ethyl acetate, take the aqueous part and do the basification and then do the extraction as I was discussing. So in that case, like if it is acid sensitive compound, so you can do one thing, just do a bulk protection by using ditertiary bicarbonate. Okay, so that is BCT or something like this in potassium carbonate and THF. There are lots of literature process or procedure like to get the product, but normally I have done here with this method bulk protection by using this potassium carbonate THF and at room not room temperature, actually reflux. So at reflux, like since THF, so you can do like 60 to 70 degrees Celsius. So in that case, you will get that nitrogen, one hydrogen will be there and another nitrogen will be like this. This is a bulk protection. So once you do one bulk protection, if you use one equivalent, like certain equivalent, so you can get the bulk protection. And if you have any question about that bulk protection, just ask me in the comment section, I can tell you. So once you get that bulk protection, then you can easily purify this compound by using the silica gel. You can ask like, still it has a one proton, but it is okay. Like it will not create any problem. It moves with very nicely.
Because it's an amide also.
Yeah,
right?
this is a kind of amide, like amide. That's why it moves very nicely.
Yeah.
So once you purify that compound with the column, like column technique, so whatever compound you have the bulk protected part like NH, so in that case you can get the free amine again. Just what you can do, 1:1, use TFA, trifluoroacetic acid, into CH2Cl2 DCM, 1:1 ratio, and do it initially add at 0 degrees Celsius, and after addition just run at room temperature for 3 hours at least. So you will get your original product with the free amine.
And pure.
And pure, it should be pure because you already purified the bulk protected one through the column, and once it is done, then you can just remove with the TFA CH2Cl2, and then once the reaction is done, then just basify the reaction by using the sodium carbonate, because your amine will be free. Otherwise, since it is acidic, so it will be in salt form. So use the sodium carbonate aqueous solution, basify it, make it free, and then do the extraction with the dichloromethanol acetate. So you can get those steps are a little bit tiresome. Like you have to do a little more work, but it is a quickest and nicest way to purify the amine. So I hope these two method will help you to purify your amine. If those are not working for you as a last point, maybe you can try with the silica gel column by using triethylamine, but do not use triethylamine too much. Just a little bit, like 0.5% or 0.4%, and then run through the silica gel before loading your compound. Even if you load your compound with the dry load with the silica, so in that case also, first dissolve your compound, okay, and with the DCM, and add 1% triethylamine in that crude also, and then you will add your silica gel, because or you can do one thing, first treat your silica gel with the solvent like DCM with 1% triethylamine, and that part add your crude mixture to make the powder, silica powder for the load. But if you want to do the wet load, it's fine. But in that case, make sure that your column is pre-treated with the triethylamine containing solvent. So hopefully it will help. So thank you for watching.
Make sure you subscribe. He has a PhD. So that all makes sense. But what if some of the impurities, at least one impurity, is also an amine?
And your final product is also amine.
And the final product has an amine. So if you protonate, that'd be problematic, right? Because both will be protonated and both will end up in your aqueous phase, right?
Okay, that is a very good question. Yeah, it also can happen. Like suppose you are making amine, and one of your side product also giving you the amine, and then you want to purify it by doing this acid protonation, make it aqueous phase, and then basification again, and then extraction. In that case, you will get both amine there. But still, you can handle it by combining both of the method. What I say to you, like first this method, and the another method is bulk protection. How? So suppose you make an aromatic amine, okay? And suppose you had somewhere bromo or something, and like you made actually nitro, okay? So you made somehow NH2 and maybe bromine, and sometimes bromine can be debrominated, or like for some reason it formed just this, like without bromine, like both are amine. So in that case also you might have some other organic impurity, okay? So in your crude, your target compound amine and debrominated amine or like something amine and other organic impurities. So in that case, you can do that acid treatment. So in that case, organic impurity can be removed, but these two amine can be go to this aqueous phase as a salt, and then if you do the like basification, then you can do a ethyl acetate extraction again. In that case, it will free to 2 amine. Then you can do bulk protecting. So once it is bulk protected, another is bulk protected, at least they will be a little bit different in the TLC, or like you can try with that one. So if they're like a little bit different, then you can purify with the column, and after that do the TFA method, like use TFA DCM. Then your bulk, after separation, your bulk protected group will be gone, so you can get the pure amine.
Ooh, fancy.
You understand?
Yep, cool trick.